Hello students, welcome to the second lecture on the lecture series on probability. So previously we have covered what basic concepts of probability and we also discussed some types of problems. So what we will do in this lecture is we will cover some exercise problems, okay, so that all the concepts that you have already learned you could get a better grip at those concepts, okay. So let's start this lecture and do some exercise problems. So let's start with problem number 1. So what is the probability of rolling a fair six-sided die and getting a even number? Okay, so you know that when you roll a six-sided die, okay, the only options that you have is what? 1, 2, 3, 4, 5 or 6, right? Only one of these options can arrive, okay. So it tells us that the event is what? Getting a 2, 4 or 6. Okay, so event is equal to, so the event set will be what? 2, 4 or 6, right? So as you can see right from here, the cardinality of E, that is how many elements are in there in the set, is equal to what? It will be 3, right? So we know that what is the formula for probability of E. So probability of E is given as what? Number of favorable outcomes. So number of favorable outcomes, okay, divided by number of total outcomes. Number of total outcomes. Okay. So basically here you have two values that you need to put in the formula. That is number of favorable outcomes. Okay. So number of favorable outcomes. So what are the favorable outcomes? They are 2, 4 or 6, right? So number of favorable outcomes will be 3. So this set contains 3 elements, right? And what are the number of total outcomes? So these are the number of total outcomes: 1, 2, 3, 4, 5, 6. Okay. So it will be what? It will be 3 by 6, right? So that will be 1 by 2. So as you see that the probability can only be a value between what? 0 and 1, and the value is 0 and 1. So you can also verify that it also what? Satisfy all the properties of probability. So another question must be what? Arriving at your head, that what is the probability of getting a odd number, right? So let's see about getting a odd number, right? So in this scenario, what will happen is your event space, let it be u1, it will be 3, 5, 1. Okay, so these are the favorable outcomes. Okay, 1, 2, 3. So cardinality of e1, that is how many numbers of elements are there in the set, is equal to what? It will be 3, right? So number of total outcomes is what? Number of total outcomes is the same, that is equal to 6. So if it is denoted as A, so cardinality of A is equal to what? 6, right? So the same formula goes for here also. So it will be P of E1 is equal to what? Number of favorable outcomes. So number of favorable outcomes are what? 3, right? So 3, and number of total outcomes, that is 6. So it will be 1 by 2, right? So this one. So what is the probability of rolling a fair sided die and getting an even number? It will be actually 1 by 2. And if we replace the even with odd, then also the answer remains same. Okay, as you can also see out right from here, these two events are actually mutually exclusive events. Okay, so if this event happens, this event can never happen. So if you get an even number, it is never a odd, right? Are there any number which is also even and odd? Okay, no, right? So let's go forward with the next problem or see the step-by-step solution. So what we do is we identify the possible outcomes, or we also say it as the favorable outcomes. Okay, favorable outcomes. Okay, so even numbers, that is 2, 4, 6, and the total outcomes, that is 1, 2, 3, 4, 5, 6 on a 6-sided die. So these are the total number of outcomes, that is 6. Okay, and the number of favorable outcomes is 3, right? So we calculate the probability how? That probability is equal to number of favorable outcomes by number of total outcomes, that is equal to 3 by 6. It will be equal to what? 1 by 2. So let's go forward with problem number 2, right? So if you have a standard deck of 52 playing cards, what is the probability of drawing a red card? Okay, hearts or diamonds, okay, at random. Okay, so basically what you have is you need to calculate the same, that is the probability formula for probability. Probability is what? Number of favorable outcomes divided by number of total outcomes, right? Number of total outcomes. Okay, so if you are getting actually a red card, then it is either a card of hearts or a card of diamonds, right? So it will be what? It will be 13 plus 13, that is equal to 26, and number of total outcomes will be what? 52, right? So it will be 1 by 2. Okay, so because what? The number of total hearts are 13, right? And number of total diamonds is what? 13. So summing these two, what we are left with is 26. So number of favorable outcomes will be what? 26, and number of total outcomes is 52, because there are 52 playing cards. Okay, so let's see the step-by-step solution. So count the number of red cards, that is hearts and diamonds, okay, in a standard deck of 52 cards, which is what? 26, right? 30 plus 13, because hearts, there are 13 hearts, that is 1 heart, second heart, 2 heart, and up to what? Queen and king. And same goes for the diamonds, and you have 13 and 13 cards right here. So probability is what? Number of red cards by total number of cards, that is equal to 26 by 52, that is equal to 1 by 2. So let's see problem number 3. So you have a bag with what? 10 red balls and 5 blue balls. Okay, so the only two kind of balls that you have is one is red and one is blue, right? So the quantity it holds is 10 and the quantity it holds is 5. Okay, 5 blue balls are there and 10 red balls are there. So what is the probability of randomly drawing a red ball, okay, not replacing it, and then drawing another red ball from the same bag? Okay, so since you have what? A bag, so the concepts of permutation will be eliminated here, okay, because in permutation what? So permutation means order matters, right? But here you have in a bag, so you can't never order them, okay, so you can never order them, so it will be not possible here. So the only concept that we'll use here is the concept of combinations. Okay, so there are basically what? 10 red balls and 5 blue balls. Okay, so what is the probability of randomly drawing a red ball, okay, and not replacing it, and then drawing a red ball? Okay, let's try to break it down into what? 2 steps. First, what we do is we draw a red ball, right? So number of total favorable outcomes is what? So probability of E1, where E1 is equal to drawing a red ball. Okay, so this will be equal to what? So this will be equal to 10 by 15, because total number of balls will be equal to what? So because total number of red balls is equal to 10 red balls, right? And total number of balls is equal to total balls is equal to 10 plus 5 is equal to 15, right? So that is why 10 by 15. So it will be 2 by 3, right? If we divide by what? 5, that is the HCF of 10 and 15, right? That is the highest common factor. Okay, so we have got P of E1, that is randomly drawing a red ball, okay, and not replacing it. Then what we do is we don't replace it. So how many balls are remaining? So after getting a red ball, so number of red balls remaining is what? 9, and number of blue balls be 5. Okay, now what is the, let E2 be? E2 is equal to number of drawing a, so it will be drawing a what? Red ball without replacement. So what happens now? So P of E2 will be equal to what? Number of favorable outcomes. So number of favorable outcomes is what? Because there are only 9 balls are remaining. So 9 by what? 9 plus 5 is equal to 14. Okay. So what is the probability that since these two scenarios are what? Mutually dependent, so we can't use the formula what? P of A intersection B is equal to P of A into P of B. Okay, we can't really use this, but what we can use is we can use P of A given that B has happened, or the formula for the conditional probability. We know that the formula says that P of A intersection B divided by P of B. Okay, so this is what conditional probability gives us, right? So if we denote these two scenarios right here, okay, and use conditional probability, we can actually arrive at the solution, because we can't use this formula, that is probability of A intersection B is equal to probability of A into B when these two are independent events, right? That is not the case here. So we have got the first probability of E1, this is equal to probability of E1, right? That in the first slot we take a red ball, okay, then what we do is we get in the second slot and get the red ball, okay, without replacement. So it will be, so this is equal to probability of E2. So to find the probability of both the events happening, 10 by 15 into 9 by 14 is equal to 2 by 3 into 9 by 14, that is equal to 3 by 7. So let's see problem number 4. So in a class of 30 students, 15 students play basketball, 12 students play football, 8 students play both the sports. Okay, what is the probability that randomly chosen student plays either basketball or football? Okay, so total number of students is 30, and out of which, so 30 are the total number of students, out of which 15 play basketball, okay, and 12 students play 12 play football. 12 students play football, okay, and 8 students play sports, both the sports, and 8 students play both. So plus 8 plus 8, okay, 8 student both. Okay, so what is the probability that a randomly chosen student plays either basketball or football, okay, or both? So what we need to do is we need to add these two numbers, okay, that is adding the number of students who played basketball and the number of students who played football, because 15 students played basketball and 12 students played football, so the sum comes out to be 27. So step number 2 is subtract the number of students who can play both sports 8 from the total, that is equal to 27 minus 8, that will be 19. Okay, so the probability is basically 19 by 30. We can also use it, actually evaluate this number via the method of set theory. Okay, so let's see how we can evaluate it. Okay, so basically we have a formula in set theory that says that cardinality of A union B, cardinality of A union B is equal to cardinality of A plus cardinality of B minus cardinality of A intersection B. Okay, so basically let's say the set A denotes, so A denotes basketball students, okay, and B denotes the football students, the students that play football. Okay, so basically A union B, cardinality of A union B is equal to so it will be cardinality of A, that is equal to 15, then we add it with 12, because cardinality of the students that play football is equal to 12, and cardinality of A intersection B, because 8 students play both the football and basketball, so A intersection B's cardinality is equal to 8, right? So we negate 8 from it, so what we are left with is 27 minus 8, that is equal to 19. So how we evaluate probability? Probability is equal to number of favorable outcomes divided by number of total outcomes. Okay, so it will be equal to number of favorable outcomes is 19 and number of total outcomes is number of total outcomes is 30, because there are 30 students, so it will be actually it will be 19 by 30. We can't actually simplify it further, because 19 is a prime number. Okay, so the probability comes out to be 19 by 30. So problem number 5. A factory produces light bulbs and 95% of them are of good quality, while 5% of are defective. So if you randomly select 3 bulbs, what is the probability that at least one of them is defective? Okay, so you have a factory which produces light bulbs right here. Okay, and 95% of them are of good quality as they work. Okay, and 5% of them are defective, that they come out to be not working. So if you randomly select 3 bulbs, what is the probability that at least one of them is defective? So calculating the probability of not selecting a defective bulb in one draw is equal to what? 95%, okay, of not selecting a defective. Okay, so if E is equal to selecting a defective one, then EC will be what? EC will be not selecting a defective one, right? So if selecting a defective one is equal to what? Probability of EC will be what? 1 minus probability of E. The formula we have learned in the first class where we discussed all the concepts. Okay, so it will be 1 minus. So probability of E is what? Selecting a defective one, right? So actually out of 100 bulbs, 5 comes out to be defective. So it will be what? 5 by 100. Okay, so it will be what? 95, 0.95 actually. Okay, so it will be 0.95. That is written right here. Okay, so which is 95%. So we have calculated the probability of not selecting a defective bulb in one draw. Since the draw are independent, because drawing one does not affect the other, because the factory produces bulbs regularly. Okay, the number of bulbs doesn't come down or does not decrease. So calculate the probability of not selecting a defective bulb on the 3 draws will be what? 0.95 into 0.95 into 0.95. Why, you must say? So it will be probability of A intersection B is equal to what? When A and B are mutually independent. So it will be probability of A into probability of B, right? So if we have 3 mutually independent events, so let's say probability of A intersection B intersection C. Okay, that is what we want to evaluate. And this one is event. So basically their intersection is also an event. Okay, so we can actually denote it as E1 or E dash, let's say, EX, let's say. Okay, so we can denote it as EX. So this will be equal to what? Probability of EX intersection C. So this will be equal to what? Probability of EX into probability of C. And we already know probability of EX is equal to what? Probability of A into probability of B. Then we multiply probability of C. So since all of these are what? Mutually independent. So that is why we have multiplied it thrice and we have arrived at the conclusion this. So to find the probability of at least one bulb, okay, to find the probability that from all of these at least one bulb is defective, subtract this probability from 1, because you didn't get what? Any defective. Okay, so E is equal to E. Let's take it as F. So F is the set where none of those 3 bulbs were defective. Okay, then FC will be what? At least one was defective, right? So this will be what? So we already know that probability of FC is equal to what? 1 minus probability of F. And we all know probability of F we have rightly evaluated here. So it will be what? 1 minus 0.0857375. Okay, so the answer remains out to be this one. Okay, so let's see problem number 6. So you have a jar with what? 100 marbles, and there are 30 red, 40 green marbles and 30 blue marbles. So if you draw 5 marbles without replacement, what is the probability that you get exactly 2 red, 2 green and 1 blue marble in any order? Okay, so what we have is 100 marbles, okay, and there are basically 30 red. So 100 marbles, and out of which 30 are red, right, and 40 are green, 40 green and 30 blue. Okay, so adding these 3, we are left with what? 100. So we have what? Described all the 100 marbles. Okay, they are of 3 colors: 30 are red, 40 are green, and 30 are blue. So if you draw 5 marbles without replacement, what is the probability that you get exactly 2 red and 2 green and 1 blue marble? Okay, so calculate the probability of getting 2 red marbles. So getting 2 red marbles. Okay, so out of 100, getting a red marble in first draw is what? It will be 30 by 100, right? So after that, what we do is we minus 1 from 100 because we have already drawn a red one. So the next case becomes what? 99, out of which 29 are red, 40 are green, and 30 are blue. Okay, now the probability of getting a red will be what? 29 by 99, right? Then after that, getting a green one will be what? Getting a green one will be, because the next scenario will be what? 98, where red are 28, green are 40, and blue are 30. So then getting a green one will be what? 40 by 98. Then multiplying it with what? 39 by 97. Because the next scenario will be what? So it will be 97, out of which 28 are red and 39 are green and 30 are blue, right? So then we multiply with what? Then we multiply with 30 by 96. Okay, then we multiply by 29 by 95. Okay, because right now we have drawn what? 5. Okay, we want to only pull 1 blue marble. So this will be the answer. Okay, so calculating the probability for drawing 2 red marbles. So it will be 30 by 100 and 29 by 99. Because after drawing 1 red marble, what we are, number of red marbles left is 29 and number of total marbles left is 99. So next, calculate the probability of drawing 2 green marbles. Okay, so it will be 40 by 98 into 39 by 97. Okay, so calculate the probability of drawing 1 blue marble. It will be 30 by 96, because after this, the number of blue marble remaining is 30, but number of total marble remaining is what? 96, because 4 marbles are already drawn, that is 2 green and 2 red. So multiplying this probability together to find the overall probability. Okay, so it will be 30 by 100 into 29 by 99 into 40 by 98 into 39 by 97 into 30 by 96. So this will be the correct answer. So let's go forward with problem number 7. So you have a deck of 52 playing cards. So if you draw one card at random and don't replace it, so basically you picked a card and didn't replace it, then what is the probability of drawing an ace, any suit? Okay, so identify the favorable outcome. So there are actually 4 aces in the deck of what? 52 cards, one deck from diamond, one from, so from the 4 categories you have one aces. So basically you have 4 aces. Okay, so calculating the probability. So probabilities formula is what? Number of favorable outcomes, that is number of aces right here, and number of divided by total number of cards, that will be equal to what? 4 by 52. 4 by 52 is equal to what? 4 by 13 into 4. So it will be equal to 1 by 13. So let's go forward with problem number 8. So you have a bag with 10 red balls, 5 blue balls. Okay, so if you draw one ball, record its color, and then draw another ball without replacement, what is the probability that both the balls drawn are red? Okay, so we have a bag with 10 red balls. So 10 red balls, 5 blue balls. Okay, so total what? 15 balls, right? So if you draw one ball and record its color, then draw another ball without replacement, what is the probability that both the balls drawn are red? So in the first draw, there are 10 red balls, and so total are what? 15 number of balls. So total probability of drawing a red ball is equal to what? 10 by 15, right? Because the number of favorable outcome is 10 and total number of outcome is 15. So after the first draw, there are 9 red balls right now, and 14 as total number of balls. So the probability of drawing a red ball on the second draw without replacement is this one. Okay, so to find the probability of both the balls being red is what? Multiplying the probability, that is equal to 10 by 15 into 9 by 14. Okay, so let's go forward with problem number 9. So you have a jar with what? 13 red marbles and 3 red marbles and 7 green marbles. So if you draw 2 marbles without replacement, what is the probability that both are red? So in the first draw, there are 3 red marbles, right? 3 red marbles. Okay. So what we do is, we take a red marble, right? So number of total favorable outcomes by total number of outcomes, that is equal to 3 by 10. So the answer will be 3 by 10. Okay. So in the next step, what we do is, there are now number of remaining red marbles is 2 and number of total red marbles is equal to 9. So the probability remains out to be 2 by 9 if we draw the second ball without replacement. So to find the probability that both the marbles are being red, we multiply both of them. Let's see problem number 10. So in a deck of 52 cards, what is the probability of drawing 2 cards, okay, one after the other without replacement, such that the first card is a red queen, that is of heart or diamond, okay. So and the second card is a black king, okay, spades or clubs, okay. So let's go forward and see the first scenario where we draw 2 cards one after the other without replacement, such that the first card is a red queen, okay. So in the first draw, what we do is, we'll take a red queen. So the number of total favorable outcomes is equal to what? 2 by 52, right? Because the number of red queen is equal to 2, that is equal to 1 from hearts and 1 from diamonds, okay. Then we multiply it with what? So number of total cards remaining are 51 right now, because we have drawn 1. So the second one being a black king, okay, black king, that is a king from spades or from clubs. So the total number of favorable outcome is 2, right? So it will be 52 into 51, okay. Then in the numerator, what we have is 2 into 2 is equal to 4, okay. So this will be the total probability, okay. So calculate the probability of drawing a red queen on the first draw. There are 2 red queens out of 52 cards. So the probability is 2 by 52. So after the first draw, there are now 51 cards remaining, okay, because we have drawn 1 and 2 of them are black kings, 1 from spade and 1 from club. So the probability of getting a black king after drawing 1 card is 2 by 51. So to find the probability of both event happening is equal to 2 by 52 into 2 by 51. So let's see problem number 11. So if you have a box with 6 red balls, 4 blue balls and 5 green balls. If you draw 3 balls without replacement, what is the probability of drawing exactly 2 red balls and 1 blue ball? Okay. So calculate the probability of drawing 2 red balls and 1 blue ball in any order. Okay. So probability of 2 red ball and 1 blue ball will be this one plus this one plus this one. Okay. So how? So because what we have is 6 red ball, 4 blue ball and 5 green ball, right? And we draw 3 balls without replacement, okay. So always you need to remember this part, whether it is without replacement or with replacement, because with these two scenarios the answer differ very vastly. So what is the probability of drawing exactly 2 red balls? Okay, so let's try to first find out that drawing a red ball out of this. So total number of balls is equal to 6 plus 4 plus 5 is equal to 15, right? So drawing a red ball in the first slot will be what? So it will be 6 by 15. Then after drawing 1, number of total balls remaining is equal to 14. And number of total favorable outcome, that is equal to get a red ball, is what? 5. So then we have drawn now 2 balls. We want to draw another ball, that is a blue ball. Okay. So the blue ball, how we can draw it? So we can draw it this way, that is equal to number of total favorable outcomes is equal to 13. And the total number of favorable outcome is this one. Okay. So now what can happen is, actually you can either draw this, since all we want to know is 2 red balls and 1 blue ball. This is what we want to draw, okay, in any order. So the total possibility of order is red, blue, red, 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 blue, or blue, red, red, right? Only these 3 conditions can happen, okay. So in the first case, what happened is, we draw red, red, then blue. So the remaining possibilities are red, blue, red and blue, red, red. So for red, blue, red, what will happen is, in the first slot we'll be having 6 by 15 as probability, because there are number of favorable outcome is 6 and total number of balls are 15, right? But in the second case, what will happen is, to draw a blue one, the number of total favorable outcome is 1, because only 1 blue ball is there. No, number of blue ball is 4, right? So it will be 4. So it will be 4. So 4 blue balls are there, and total number of outcomes is equal to 14 because one have been already drawn. Okay. So in order to get another red ball, what we have, the total number of favorable outcomes will be what? So it will be from 6 we have drawn 1, so it will be remaining one is 5, and what we have is only 13 options left because we have already drawn 2 balls. So this case is sorted right now. So what we want to calculate is now this case. So it will be what? 4 by 15 because number of total favorable outcomes is what? 4 because there are 4 blue balls and total number of balls is 15. And then we want to draw a red ball. So it will be total number of red balls is what? 6. So number of favorable outcome is equal to 6. And total number of outcomes remaining to it seems to be 14 because we have already drawn 1. So then total number of outcomes remaining is what? 13. And total number of favorable outcome is equal to 5 because we have already drawn red one. So then summing these 3 probabilities together, what we are left with is the probability that exactly 2 red balls and 1 blue ball are drawn. Okay. So probability of 2 red and 1 blue ball is equal to this plus this plus this. So simplifying this, we can actually arrive at the probability. Okay. So I think that's enough for today. Thank you.